Gentlemen, welcome back to the shop. On the healing bench is DeWalt's DC785 cordless hammer drill driver, half inch. In the previous video we did all the mechanicals, and in this one we're doing all the electronicals. In closing, some special modifications I made myself. Now right off the bat, this is it, man. That's the prime mover right there. Look at the size of that thing. Permanent magnet, brushed DC motor. Whoa, these are special brushes too. Let's have a peek at that. Some high-tech shit right there. So the face of the brush is grooved, I guess, just for wear in. And then the brush itself is copper impregnated. So this would be graphite, powdered metal with lots of copper in there. So there has to be some graphite in there in order to provide lubrication for the brush. But the copper is excellent because it has very high current carrying capabilities. That right there, my friends, is a premium brush. Just trying to get this rotor out. Very interesting. What they've done is they've used a shrink fit powdered metal ring that they heat up and then put on the motor shaft in order to retain it in that bearing. Then as it cools down, it's a shrink fit, won't come off. Oh, it's in there real good. Little tiny NSK bearing in the back, and of course a little tiny one in the front too. Tiny little motor. And interestingly, for something spinning at 25,000 ripms, there are no balancing slots. I don't know if that pen mark is that little bit of paint is for balance or what. And we have some sort of urethane glue schmoo on there, whatever that's for, I have no idea. This thing is so compact, and the wire, 20 thou, wow, so that's like 25 American wire gauge. Man, there is not a gram of fat on these things, let alone an ounce. As close to the wire as they can get them. Just incredible. Of course, these dimpled Spade connectors, I do not like these. Some guys swear by them. I don't like them because, as I said before in the previous video, basically it gets dropped in water, yada yada yada. You have all these dissimilar metals. These are going to corrode. They're going to loosen up, and then the thing's going to work. Sometimes it's not going to work. Other times you'll have high resistance through here. It'll get super hot, burn up. It's just not the way to go. When I'm elected benevolent king of the world, we're going to outlaw these and legislate the tool manufacturers into soldering these on. Oh, that's cute. This is cute. Oh, God. Look at this. Where'd it go? Where'd it go? Where'd it go? Where'd it go? Okay, you see how the preload spring on the brush is... That is a lovely little detail. They put a little tab on there to ease the assembly so you can pull back the spring and retain it in that tab, and then bring, oh no. Oh yeah, and then bring out the brush, and the tab or the preload spring doesn't go fucking off on you. Like that. Cute. Very cute. All your power is coming out of this. All of it. 175 grams. Tabarnak, ça fait pas d'allure. Franchement. We'll do a horsepower calculation, but I got a feeling this thing will put out a 1/4 horsepower. Another little thing that's interesting about this, and I've seen this on high voltage slip rings before, is the commutator bars are actually grooved. Normally they'd be polished smooth there, but these ones are grooved. So does that make better contact, or does it make more arcing? Well, she ain't big, but she sure is pretty. Straight blade impeller, of course, because it's got to turn forward and reverse. And if you look down there at the windings, they also are epoxied at the bottom of the winding, and that's where they break a lot of times. So that is excellent. It belongs in a dinky car. It's, yeah, crazy. Now we come to the brains of the operation. There is going to be some computer chippery in here. And that's in order to control the speed. So starting from the battery, bat neg, bat positive, and we've got some temperature sense. So if the drill's working really hard and the battery gets too hot, this thing will not work. It'll shut down. There'll be a little computer monitoring the temperature of the battery. Now what we see on the backside is a lovely copper heatsink. And this will be attached to a MOSFET. That'll be the switch that this brain box is using. It's essentially a relay, and that thing gets hot. I like to see copper because it's got twice the thermal conductivity that aluminium has. It's probably 4 times the price too, but that's nice to see. And here we can see spot welded as a protection diode. Let me show you why we have a protection diode in there. This thing at the first of the stroke, it actually does have a switch. So if you're going full speed and you let it go, what happens is you've got the battery positive here, you've got a closed switch, and you've got the motor. This is an inductor, basically an electromagnet. You got all this current rushing down into the negative. We're not going to degrade ourselves by getting into a conventional versus electron theory debate, but you've got all this conventional current going into the negative. And then all of a sudden we open that switch. You've got all this built up magnetism here that's you gotta get rid of it. If you don't get rid of it, you have this huge voltage spike. And remember, this switch is actually sensitive electronics. So what we do, we put a diode here. So now when the switch opens, instead of the current going right to ground, it can do one of these, and you don't get a huge voltage spike that burns up your electronics. Now that first click there on that switch just to power it up is super mush. No es bueno. But the forward reverse, it's not the snap action of the switch, it's actually the detent. Real beefy. Ka-chunk. Now we can see we've got the heat transfer compound. Yeah, look at that. That's that diaper rash cream on there. And there's our little switch. That'd be a MOSFET. Essentially a relay. So this electronic stuff, it can't handle the 20 volts, or actually the switch. Pretty telling here. You see the switch is rated for 11 amps, 18 volts DC. But the electronics in this can probably only handle 3.3 volts, maybe 5 volts, depending. The 18 volts would fry it, so it needs a relay in order to run that 18 volts. I got some hot snot on there. It's giving us a little bit of trouble. Dangerous tool on the claim right here. And for you guys just joining the channel here, remember my motto, cut towards your chum, not your thumb. Okay, pretty action packed in there, yeah? You can see the mechanical switch for the reverse here. Oh, sproing. Feck. Now this is pretty incredible. It goes to show what a fantastical age we live in. There's the brain right there. That little push, maybe like 2 millimeters by 2 millimeters. And this is the MOSFET. This is the relay switch essentially. This little guy, rated for 230 watts. So 230 divided by 747 watts per horsepower. That's over a quarter and under a third. That'd be just a blonde, well, not a blonde one shy of a third, but we'll say a caramel brunette one shy of a third of a horsepower this thing can handle. Incredible. So that's why we need this big beefy heatsink here. So essentially the way this works is there'll be a switch that gives power to this, and then there's also a potentiometer that sends an analog signal, so just a voltage signal. As it wipes along, it's built into the board, the potentiometer, and then this little brain box will read that value, turn on and off this MOSFET so quickly that it varies the voltage. If you look at this on the oscilloscope, you'll see square waves. It's called pulse width modulation. And the motor, all it sees is change in voltage. So if you want a quarter speed, you might see 10 volts. If you want half speed, you might see 12 volts. If you want full speed, you get the full meal deal, 20 volts. And then the forward reverse is done the easy old-fashioned way, just with a switch It just swaps the contacts. And the trigger mechanism here, it's even got a cute little felt wiper to keep the schmoo out of there. Okay, I'm no 8-year-old Chinese girl, so wish me luck on getting these contacts back in. You got the D10 spring here. You got the contacts all preloaded. You got grease all over the goddamn place. Oh, fuck, this sucks. Come on, you fucking cut cork stuff. Woohoo! Booyah! Take that, you sausage finger pointing mother truckers on YouTube commenters. Like a cat, buddy. Like a cat. What the hell kind of contraption is this? Well, my friends, picture is worth 1,000 words, a movie is worth 1,000,000. I'm going to show you what the motor sees. Here we have a resistor bank, homemade, as you can see. You can't buy cool stuff in the stores anymore. You gotta make it yourself. This is just Hastaloy stainless steel filler rod, welder filler rod. Now if we look at the resistance here, it's essentially 0. Yeah, 0.6 ohms, very low. And then concatenated in, we got the switch, the brain box, the terminal. I'll stick the battery on the pokey bit here, and we'll turn on the oscilloscope and see what is going on. You hear that pulse width modulating? You see how the tone doesn't change? I'm going to show you what pulse width modulation looks like. What that brain box is actually doing is sending pulses to the motor, and depending on the on time, the width of the on time, it has a different voltage. Of course, voltage in this motor equates to speed. Okay, here we got the scope set up, and you see the frequency is 4 kilohertz. That's why we hear it plain as day. They could easily turn that up to, say, 20 kilohertz, and then we wouldn't be able to hear it at all. It'd just drive all the teenagers away, because us old fuckers don't hear that high in the register. And the top of the mark there is at 20 volts, but the average is maybe 3 volts. Then all that happens is the width of the pulse increases, the time, the on time increases, and the average voltage goes up. So right there, we're probably running at 10 volts, half the battery voltage. Now if we give it full voltage, that's it right there, full on. So that is what the motor is seeing, all those pulses. But they're so fast, they're 4 kilohertz, they're so fast that the motor doesn't even notice. It just thinks it's getting an average voltage. 1 volt, 6 volts, 10, 12 volts, 20 volts. Now, what is the full battery voltage? 18 volts is the full battery voltage. Interesting how it's fully charged, and they would say 20 volts on the outside of it. Well, just for shits and giggles, I got the crimp on ammeter, and we're gonna give her a while. 3 amps. Wow. 17 amps that thing will put out. So that's pretty impressive, because even at the actual voltage, the 18 volts and not the rated voltage, the 20 volt wank marketing number, 18 volts times 17 amps is 300 watts. For a motor this size, 300 watts? Fuck, incredible. And there is no protection for this little motor. The protection is all for the battery. If the battery over temps, it shuts down. But there's no sensors, nothing on this. So you could fry the hell out of this. Just like the Makita, there was that wank marketing commercial a while ago where the Milwaukee would shut down and the Makita, the guy would burn it out. But I would prefer to be the one to choose when to turn the machine off rather than have a computer decide for me. There's nothing worse. You're halfway through a cutter. You just got to drill one more fucking hole and the thing shuts down on you. Well, I would prefer to have the responsibility of, and that is a good thing to me so that you can finish your hole or whatever. And if it gets a little smoky, you'll smell it. Don't let the computer make the decision for you. You got to make the call yourself. Deal with the consequences. So that's a good thing that it's not protected. Instead of covering their ass trying to reduce warranty claims and all that stuff, they put the power back in your hands instead of in the computer's hands. I like that. That's a good feature. I figured with all the shit and abuse we just gave it, this would be pretty hot. Cool as a cucumber. Here we got the field magnets. Just those cheapo sintered ferrite type thing. But look at this. Already got some chunks taken out of them. Yeah, right there. And right there. Which in and of itself is no big deal. However, how did the chunk get taken out? It had to have gotten whacked. And a whack in a magnet makes it weaker.
Tihomir, jel ti se sviđa mašina? Jel znaš ti s tim raditi? Ajde da vam pokažem. Bravo. Bravo. Dobro, dobro, pregrijat će se, čuješ? I to si sve napravio za sat vremena, kažeš? Bravo. Bravo. Svaka čast. Bravo.
Oh yeah. That'll fit. I'll split the lithium-ion battery here. Have a peek. See, the plastic enclosure was made the second month of 2015, and these are Sanyo cells, 18650s, SKDX4A something something. Where we got the charger? I got it unplugged. Basically, it's an empty plastic box. This is a switch mode power supply. We'll just go over what's happening now. Lithium ion is interesting. It's a great technology, but it requires special charging. First off, it needs constant current until it reaches a certain voltage, and then it needs to switch over from constant current to constant voltage. So it'll input, say, an amp until the voltage gets up to 3.8 volts. I don't know what it is, I'm just pulling that out of my ass. And then once it's at a certain voltage, 3.8, good a number as any, then it bumps up to 4.2 volts and then just trickle charges until it like tops it up until it's fully charged. But these, the thing is with these is they're fast charged. Like you can charge one from dead to full in an hour, which is crazy. So that really depends on the C rating of the battery, and that's how much discharge and charge it's able to take. So those are super good batteries in those packs, and they can take quick charging. So here we have the Pixies input from the wall, 120 volts, little fuse here. Here's a filter capacitor. This is not to protect this, it's to protect the stuff, all the stuff connected to your house from the high voltage noise or the high frequency noise that this produces. Now here we've got a little transformer, and then look at these 4 cute little diodes, 2 one way, 2 the other. That constitutes a rectifier, and basically the AC gets switched into DC, and then it gets filtered by this 100 microfarad 200 volt filter cap. So you got AC coming in, it gets switched to DC pulses, and then this filter cap filters it out. So this is a switch mode power supply, and these little switches here are MOSFETs. And what's happening here is it takes the DC and it switches off and on very quickly, like thousands of hertz. Actually, yeah, probably 50 kilohertz, 50,000 times a second it switches. And it feeds it into this transformer. This transformer takes that 120 volts or whatever it is out of this guy. Transformers only work on changing current. It doesn't work with straight DC. So that's why we need this chopper here to chop up the signal into pulses. And then we're sending that pulse signal into here. That lowers the voltage. And then we have caps, filter caps, some other passives in order to control the charge going to the battery. And if we look on the back side here, we can see the brains of the operation. We've got a couple of charge controllers and a microcontroller. So what this will be doing is monitoring the balance of each cell in the battery, making sure each one gets balanced, and then charging it up, monitoring the voltage and the current and all that sort of stuff. So if ever your charger craps out on you, interesting thing, cute little detail here. So this is a big capacitor. If you just plug this into the wall and take it out, it'll be powered up. You know that old joke you used to play in high school? You'd stick it in the socket there and then you toss it at your buddy and he'd catch it and get a shock. Well, you'd get a shock if they didn't have these bleed down resistors. Now normally you would just have one through hole bleed down resistor, but this is, I checked it, 3 mega ohms, and I guess they couldn't get surface mount stuff to be 3 mega ohms, so they got a little, check that out, a little ladder here. So I might have gleaned over this, but the little brain box here, is it this guy? No, LM. Some of these are battery controllers. There will be one main microcontroller, and the microcontroller, we don't want to fry it, so it turns these guys off and on. It puts power to the gate on these guys through these opto isolators, and in here is actually an LED and a receiver. There's no actual electricity going between here and here, because if something happens with this, it would fry it. Now if you ever have a problem with this, you can take it apart. Even as a layman, take it apart and just look to see if there's any burnt components. And if there are any burnt components, if you can read the numbers off there, all you got to do is desolder it and change the component with the like component. Jean-Guy's your uncle. Like I say, if it's not working, it's already fucked. You're not going to fuck it any more than it is. You might as well take it apart and have a boo. And get her back together. What do you think? You're going to fart, turn a 1/4 inch, let the smoke out, or will she chooch? Choochie. We're actually going to see how fast it turns here.
Dinner.
Thanks, love. Well, you can call me whatever you want, just don't call me late for dinner. You heard the lady? I guess we got time for one more test though. It's in 1 gear. Ah, even slower. 576. Next gear. Holy, that brake. Wow. That stops right now. Huh, that's interesting. That's that clutch mechanism in there that's stopping right away. Well, passed the old smoke test. Nice and torquey. I'll give it that. Stop. Hammer time. So you paid the extra 150 Canadian pesos to get yourself a hammer drill. So we're going to test this bad mamma jamma out. Garbage! And that is why it is far better to go and rent a proper rotary hammer when you want to drill some holes in stone or masonry, rather than forking out the extra dough for the hammer feature, because it's just garbage. And you see here, 34,000 beats per minute. All that is those sawtooth little cuts on the back of here. So if we go 3,400 divided by 2,000 RPM, that means there's 17 teeth on there. So, the classic maneuver, right? The higher the number, the better it is? No. If that number were lower, it would hit harder, because the ramp, they could fit bigger ramps in there. So if they had 5 on there, then it might actually do some effective drilling, but they don't. So, and yes, the black and yellow fanboys are going to be all up on my Kool-Aid, because this is for masonry only. And I was drilling a 6,000-year-old rock. However, if you're drilling concrete, it's got pea gravel aggregate in there. So if you hit if you hit one of those stones, you're hooped. It's not going to drill through. Well, there you have it, gentlemen. Man, a lot of engineering went into this. Not to make it particularly robust, but to make it just good enough. Still, 300 bucks. I don't know, man. Thanks for watching. Keep your stick on the ice. Oh yeah, that little doodad I put in the handle. That's something for another time.